Hi there, my name is Tim, and I am working at Purdue University as an intern with the Trails program. So today I will be showing you how to make a 3D model of a Opihi limpet from Hawaii using the Onshape design software. So here's what our model is going to look like. It's just a cone with some ridges around the edge. You can see it's a perfect circle there. It's hollowed out. And here's what the Opihi actually looks like. So you see it's pretty conical, cone shape, pretty sharp there, but it's not perfectly a circle. So because of that, I have a complex design that is a little bit more complicated to make, but is more based on the actual shape. So that will be my next video. First, here's the simple Opihi. So to start out, this is what it looks like in Onshape when you start a document. Make sure you get familiar with your mouse of holding down the right click is to rotate, holding down the middle click is to pan, and then scrolling with the middle click zooms in and out. And basic features, basic design for any 3D design software is you make sketches, which are 2D shapes on a plane, and then you use those sketches to make 3D shapes using tools like extrude, revolve, sweep, loft, and thicken. So first, what we are going to do is make the cone, and I will actually show you three different ways to make this cone, but first I'll make it um, using a revolve function. So let's get back to our normal view here, front, right, top. So I click sketch, I click front plane, I click front view. These are all just simple left clicks. And then I am going to make the shape that I will revolve. So what this revolve function does is it takes a two-dimensional shape and rotates it around an axis as far as you want. So what we're going to do is we're going to make a small trapezoid-like shape and then rotate it 360 degrees to form our cone. So just start with line, click on line, make sure it's centered here, click on this axis, click on this axis, go horizontal, click on this axis, and then click on this point. And click dimension, and we can change our angle here. So click this line and then click this line, and that gives us our angle. We want 45 degrees. Click this line and click this. That gives us our angle, 45. And then how tall do we want this to be? Click from this point to this point, and we want that to be 1.25 inches. I'm working in inches here, so make sure that when you start your design that whatever units you're working in are specified. So 1.25 inches tall. These are symmetrical, so or parallel because they're the same angle. And then the last thing is to determine how far away these are, how long that is. So I will make this a half an inch thick, 0.5. No, that's a bit too big. Let's do 0.25. There we go. So that is our general shape. That looks good to me. I can pan around, rotate to see if it looks good. Everything looks good, so I will click check, and there is my first sketch. And now to do the revolve function, we click, make sure our whole sketch is highlighted. Click on our sketch, click revolve. We want a new solid. Um, so our axis, click mate connector, select mate connector, which lets us choose a coordinate system basically. And then select the origin. Click, boom. There's our revolve. See, it's our hollow cone. Looks pretty good to me. So I will click check. Now we are basically done. Actually, all we have to do is make the ridges that you see here. Um, and then we are finished. So to do that, we're going to use the sweep function. And what that does is it takes one sketch and moves it along a path similar to the revolve function, except instead of moving it circular, it will move it along a path to create some sort of a tube like it shows here. So we'll just use this circle, super simple shape to create our tube, um, our ridge. And first we have to make that circle. So click on the front plane, click sketch, click front view, click center point circle. Make sure you're on this point here. Click, click, click dimension, click my circle, click to get the dimension, and that is going to be 0.05 because we don't want these ridges to be too thick. Click, hit enter, can pan around. There's my circle, looks pretty good to me, so I click check. And, did I do that right? Let's show our sketch. No, I did not do that right. So instead of being on the front plane, we need this to be on the right plane because we need a length to sweep this along, which is going to be this line here. So I clicked the eyeball next to this sketch so that it would show up. See, now I can see that gray outline there. And like I said, for a sweep function, we need one sketch that is going to be our cross section and another line or sketch that will be our path for that cross section. But it doesn't work if they're parallel with each other because that's just not going to do anything. It's just going to sweep sideways. So we want it to sweep that way. What I could do is I could take this and rotate it so that it's perpendicular with this line, or I could just make a new line perpendicular with it here. So what I'm going to do is I'm just going to rotate this. Super easy. Click, right click, edit sketch. And instead of front plane, we want the side plane. So click front plane, click right, and boom, it's now perpendicular. Click check, and now we're going to do our sweep. So make sure our whole circle is highlighted. Click it, click sweep. We want a new solid. Click. Have to click our circle again. Sweep path. We click that. Click this line. Make sure it's just this line and not like the whole shape. Click, and you can see there's our ridge. Boom. That's what we want. Looks good to me. And uh, yep, new. Make sure to click new again. New solid, just to keep things simple. That depends on if it's a new part down here or if it's merged with the same part. So to keep it simple, we'll make a new part. Um, yeah, there's our ridge. Click check, and looks pretty good to me. The only thing is, it's go to front view. It's kind of hanging off a little bit here, so we don't want that. we're going to use an extrude remove function, which is this extrude three-dimensional. And instead of adding a solid, we're going to remove from the solid. So here's what we do. Click sketch, click here because we're already on our front. So sketch plane, front plane, zoom out just to make sure. Yep, there's our sketch. You can see our sketch plane. Sorry. Click corner rectangle, and then just make something that is overlapping here, but not overlapping anything else. So our rectangle is over here. Don't worry about the dimensions too much as long as it's there. Click check because we're good. Now we click our rectangle, click extrude. Here is what it's doing. So solid, click remove, click through all, click symmetric, click merge with all. So that's a really easy, quick way to just get through. If you had something that you didn't want it to remove through everything, only some parts, that you could change some of these settings, but this is really easy to just click, 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 and then it's through. So we can see here it has ghosted out this base of our tube or ridge here, because we don't want that little pointy section. So we click check, and it's gone. And that looks pretty good to me. So now we're going to rotate all of these, make multiple of these around. Super, super easy. It's called a circular pattern. So we come up here, drop down circular pattern, entities to pattern, click our ridge, axis of pattern, click here, click mate connector, and then choose something in the center. Make sure it's flat. You don't want it to be angled like this, but as long as it's somewhere in the center, it will rotate the same way. So click here. That gives us 4. Or I could click down here, or I could click up here. But sometimes, like here, it'll make it angled, and that's not what we want because it doesn't actually do anything. So yeah, click somewhere in the center, and then we're going to give it 20. Enter. Boom. There it is. We've got our ridges. They're all flat on the bottom. Looks pretty good to me. Equal spacing, yes. 360 degrees the whole way around. Click, check. And that is our finished Opihi design. So, very quickly, I'm going to show you 2 other ways to make the cone using a Revolve Boolean and using a Loft Boolean. So that'll make sense. First, to start out with the Revolve Boolean, we're going to do a very similar thing like we did in this design where we made a side shape and then revolved it, except we're going to make one cone and then another cone. Click front. Yeah, we're going to make one cone and then another cone and get rid of the one in the center so it'll be hollowed out. Because we don't want this to be solid in the middle because these themselves are not solid in the middle. You see there's that gooey organic stuff, all the life of the organism. So our revolve Boolean, what we do here is start with our sketch. Click, click front. There we go. Click line. And we're going to make just a cone shape, so just a triangle shape. Click, 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 click. And if you remember, our shape here was 1.25 inches tall, and it was 0.25 inches in this direction. So that means our center cone is 1 inch tall. So this is going to be our smaller cone. So we want this to be, click dimension, click here, bring it out, click 1, enter. And then we want this to be 45 degrees. So we could do that two ways. We could either click here, and do this angle at 45, or escape. That was a right click, click escape. Click dimension, click this length, click 1, enter. So now this is 45 degrees because these are equal. Or one other way to do that is right click, escape dimension, click here, delete. And then what we do is these are like deciders that lock things into shape, such as making sure things are parallel or horizontal or perpendicular. So equal, you can click equal, click this, and click this, and that makes them equal length. Here, let me show you that real quick, how it, let me click dimension, click, yeah, yeah, I don't have to show, yeah, basically that. Oh, here, I can click here, delete, so that removes this equality here. I'll just show you real quick. Escape dimension, delete that. So, see, these are not equal right now, so I can click this equal, click on that, and then boom, it snaps them into shape. So these are very useful for any time you want things to be perpendicular or the same shape or vertical. Yeah, very helpful. This shape looks good. There is our cone. We click check. Sorry, there's our triangle that will create our cone. So for our rotate, we click revolve. We click our sketch, new solid, click axis, and we can just choose this center line here. We could use the center, like I already said. It does the same thing, but we need to make sure it's flat. We don't want it to be sideways like that, or else weird things, it's not going to do anything. So we're just going to delete, click revolve, click this center. And there is our cone, but it is solid, and that's going to be the inside. So click check. Now what we do is make our second cone so that we can have it hollowed out, and this one will be bigger. So click front, click sketch, click front view. We're going to make another triangle, just slightly bigger. Click line, click, 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 click dimension. Oh, here we go. Click equal, click here, and click here. Boom, so that locks that in at 45 degrees. Click dimension, click here. I want that to be 1.25. Enter, check, and that is not our cone yet. So what we do is we click here, click revolve. Make sure this is a new solid. We don't want to add or else it'll be very difficult to take away. So new solid, that means these are two separate cones right on top of each other. This is what we want. Revolve, click that, and then click this center line. Make sure it's new. It'll make it automatically add there. So click over to new and click check. Another way you could do this is make your bigger cone first and then make your smaller cone and revolve it and choose remove. Let me show you. Instead of new, you click remove and that would take away the shape. But I thought it was easier to see both of them as you're making them because right now you can't see the middle one. And it also helps show the Boolean function, which is super easy. So now we have these two cones. One is smaller than the other and right inside the other, which shows with this like crazy looking pattern here. So what we do is we're going to do a Boolean function, which is super easy. Click Boolean, click subtract. Pools, that's what subtracts. We click part 1, make sure it's our smaller cone. Click targets, that what it subtracts from. Click targets, click part 2, our bigger cone, and then boom, it gives us an idea of what we want. We got our hollow cone there. We could put water in there and drink. Um, but it's still kind of showing up the center, so we click check, and it is gone. And there is our cone. And then um, we already have our sketch 2, our sketch shape. We click to unhide that, and there is our line that if we wanted to make the ridges again, we would just make our circle perpendicular. Just very quickly click, click, sketch, circle. Or I can show you that it doesn't have to be a circle. It can be an arc. So we make this here. Radius is 0.05 to make it the same size as our other ridges here. So radius is 0.05, but we need to make sure it's a solid shape. So we put a line in the center. So now it's filled in. Yep, that looks good. Sketch is good. And now we can do our sweep. So I made it perpendicular this time, did it correctly. So I click sweep, new solid, click this circle, click sweep path, and click this line, and click new. It automatically does add. But that's nice to have it an arc because then we do not have to remove or extrude from the bottom. It's a little weird because I don't think it's, yeah, see, it's not actually touching up here, and down there it's a little different. So it's not actually touching along some of these edges, which is a little complicated, might make things messy when you're 3D printing. So I do not recommend using an arc. I recommend using a circle. But just to show you that you can use whatever shape you want for a sweep. Um, Let me click X, and I'll show you one more thing, how you can use a ellipse too, and that can be cool. So let me delete this sketch, sketch, click, it'll be on the right plane. Um, so I want an ellipse here. So click, click, click. Dimension, I'll make it point, oh, and this is the whole length, so I'll make it 0.1 vertically, and then horizontally, I'll make it 0.05, so it's half and half. And then this will make some steeper arcs there. So again, click sweep, click our shape, click path. We want this line, click this line, and boom, there's our ridge, and it is a bit steeper. It's a bit thicker than our other one because it's a different shape. So then I can make that, revolve it all the way around, make sure the bottom is flat if I want to. But that's just to show that you can be creative with these ridges. You can even make this shape different. Doesn't have to be 45 degrees. You could make it super flat. I can actually edit that um, with Sketch 2, edit. So I don't want these to be equal. Click delete and dimension 1.75. Boom. So that's going to be a bit steeper. Click check. And you see it's a new shape. Our center cone is still the same, but you can make this shape whatever you want. And I'll show one last easy way to make this cone, and then we'll be finished. So here is a new document. So I click top. So what we're going to do is use the loft function. And what the loft does is it takes two shapes and basically just connects them. Two sketches and connects them, which will be very helpful with our complex Opihi because this is not a straight circle, which means we can't just use the revolve function because it would make a straight cone. So simple Opihi loft. Here's what we do. So we start with the top, make a sketch, the top view, and we're just gonna make a circle. We want this to be uh through three, no, our radius is 1.25. Yeah, yes. For some reason I was thinking I needed the diameter. So radius is 1.25. Click enter. Oh, no, we're going to do the same thing where we make one cone and then the second. So I will make the radius be 1. Actually, sorry for the indecision. I will make the radius 1.25 and make our bigger cone, and then make our smaller cone and show you how the order doesn't matter. So what we do is we make our circle 1.25, click check, and then we're going to need to make a point floating up above our circle, like right about there, um, so that we can connect these. So in order to do that, we need to make a new plane. So we click top, come over here and click plane, and then it automatically makes it 1 inch offset. We don't want that, we want 1.25 inches. So click enter because our radius is 1.25 inches. Our height will be 1.25 inches. Um, Something does not look right there. With this, our height was 1.25 inches. Our radius is 1.25 inches. Okay, I think I may have messed up this sketch. Edit. Yes, this is the diameter. So I was correct. I need this diameter to be 1.25 times 2, which is 2.5. Now our radius is 1.25. And click check. So now that looks a little bit better. That's a bit of our cone shape. So here's what we do is since we have this new plane, we click on this plane and then we click sketch and then we click point. We click top view and it looks like it'll be on our circle, but since we're using our offset plane, it will be floating in the air. So we click in the center, that creates our point. We can pan and zoom. Looks good to me. Our point is floating there. Go back to top view. It's right in the center. So we click check. And now we can use our loft function, which connects this circle to this point and makes our cone. So click loft, click our circle and our point, and there's our cone. Make sure it's a new solid. Looks good to me. We can fool around with this if we want our start to be normal. That makes this perpendicular at the edge there at the bottom. Or if we want it tangent, that makes it parallel at the bottom there and then curves up. You can do the same thing at the top, normal, perpendicular. It does not like that. Or tangent, that makes it flat at the top. So you can fool around with that shape. But usually simpler shapes are easier to work with, so we're just going to go with our simple code. Click check, and then we're going to do the same thing but smaller, and Boolean that out from the center to make our hollow cone like we have here. So I'll do that very quickly. First, make our circle, so click top plane, sketch, top view, center point circle, click on the center, click here, click dimension. We want this to be 2 inches, so it's 1 inch radius. Click check. Now we need our second point, so we're going to make a new plane actually. Click top, click plane. We want this, now we do want it to be 1 inch offset. You see it's our second plane here. It's not the one we already have. It's right there, because that's how thick it will be. I could also use this plane and offset distance. Uh, delete plane 1. So offset distance we want 0.25 inches, and that's not where we want it. So we flip the direction so that it's 0.25 inches below our first point. Click check. Use this plane, make sure it's highlighted. Click sketch, go to top view, point in the center. Nope, that was not in the center. Undo, point, make sure it's top view, right in the center. And then, does that look good? Yep, it's floating there. It's not at our top, it's not at our bottom. It's where we want it. Click check, click loft. Make sure you highlight this and this point, and then click remove. And that way we don't actually have to use our Boolean function. As you see here, it says Boolean resulted in no geometry change because right near it, it's automatically adding it, but our cone is already filled in. So it's saying, why are you doing that? So I click remove instead, and that takes out our thing. And again, it's a little cone that you could drink from. So I click check, and we're good. Now the last thing is making the ridges. I'm not going to make all of these ridges. I'll just show you how, and then it's the same exact circular pattern. But the interesting thing here is we don't have any lines or any paths to sweep across, so we have to make those super easy. It's a function called isocline. So we drop down here, click, sorry, it might be covered by my video, but click isocline. It's this little circle with sphere with an arrow. It'll show up here. That's what it looks like in the drop-down menu. And which faces do we want? We want the face of this cone. Which direction do we want? We want either front or right because they're both perpendicular. We'll choose front, and then we make sure that it's 0 degrees. So that makes a line along there. And then we click check, and then we make our sketch, make sure it's perpendicular. Click right, sketch, right view, circle, radius 0.05, diameter, sorry. Check, do our sweep, this sweep path, this line, and it's cool because it actually creates a symmetrical one because it's got both of these lines. So, and something really weird is it makes it flat on this edge and pointed on that edge. Must have to do with the isocline function. But what we do there is make sure it's a new solid. So click new. Looks good to me. Click check. And then we can go ahead and extrude down here to make that flat and then rotate around. And we'll only have to rotate around 180 degrees because it's symmetrical instead of doing 360 like we did for this one. But yeah, are different ways of making a cone. And now finally, thanks for bearing with me. You've been with me. Um, I'll show you how to export this as an STL. Um, and just to make things simple, I will make this all one part using Boolean actually. So just click and drag to highlight everything. Click Boolean. It'll say union. It's loading. Click check. And that makes it all one part to make things easy because it's what we want. And sometimes if the geometry is a little funky or if it's almost perfect, it won't actually do this Boolean. It won't work. It doesn't work for our complex OPE, but that's fine. Um, and we just come over here, right click on part one, click export, and then we can name it whatever we want. We use STL from the drop-down menu because that's what we need for 3D printing. If we wanted to do other things, we could use any of these different file functions. But we want our units to be in millimeters, even though I was working in inches, because that will keep the same size. It will not say that like 1 inch is like 1 millimeter, so it's not shrinking it. It's saying that like 1 inch is like uh third 240 millimeters or however it is. Um, and then it uh makes it so that the 3D slicer software um can understand the size because most of these softwares use millimeters. And then that's how we're going to 3D print it. So we take our STL file, put it into the 3D slicer software, and then we're done. So here it is, export, download, and it downloads here. And there is our simple OP. Thank you for watching. Make sure to watch the next video if you would like to learn how to make this complex design. It's very similar to the third way I showed you with the loft function, and then using these lines, this isocline here, isocline line. So, yeah, next video, make some cool stuff.